I don't know.
Okay, a fair coin, that's just a good coin, nothing weird about it, is thrown 6 times. The event A getting all heads has a probability of 1/64, okay? Which you can actually calculate, because it's a half times 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 a half, right? If you did that 6 times, you'd get that. Describing words what AC is. Now, A with a big subscript C is the complement of A. So I want you to think of what's the exact opposite of every single one, every single time you do it, of getting all heads. So what's the opposite of them all being heads?
Them all being tails.
No, that's only half the answer. It's not the full answer. Because wouldn't one of them being a tail and the other 5 being a head also be the opposite?
Yes.
Right. So I want you to think of the world as a very small world. Let's show you a visual way of looking at it. Okay. So I'm going to imagine visually that there's 2 groups in the world. A is them all being, all being 6s, right? And that would only happen like that, agreed?
Mm-hmm.
Now, the second set, which I guess I should call the complement, is everything that's not A, right? Now, you're quite right in none of them being 6s, but a 6, a 6, a 6, a 6, a 6, and a 1 also belongs in that world, because isn't that combination not all of them being 6s?
Yes.
So if there's a 1 out of 64 chance of this happening, there is a 63 out of 64 chance of this happening. And this is basically using the probability rule of complements. And what the probability rule of complements says is that if you take the probability of something happening and you find the probability of its complement, they always add up to 1.
Got it now. I'm a visual person.
Okay, so seeing the picture helps. You could have 1, 1, 1, 1, 1 as well. 1.